name's Logan. Welcome back to the lecture hall. Today we're covering section 2.7, derivatives and rates of change. So we are going to be heavily relying on tangents and tangent lines. So we covered that in section 2.1, 2.2. So if you haven't seen those, I recommend you go and watch them because they'll help a lot for this video. Because if you don't know what tangent lines are, then you're kind of left in the water, you know? But what is a tangent line if we do a brief, fast look over it? It is a line that just touches the graph at point P with the slope of the line being the slope of point P, right? So we had one example, or another thing called a secant line in the previous sections, and a secant line is a tangent line, but it hits it at 2 points, and it's the slope between the 2 points. So the equation for the slope of a secant line is MPQ is equal to f of x minus f of a over x minus a, right? So how would we find the slope of a tangent line? How would we find the slope of a tangent line? Well, if you have any idea what we've been trending in these past recent videos, what have we used in every limit? But how do you find the slope of a tangent line, not a secant line? Well, if you've noticed a general trend in the videos recently, we've always been using limits to find stuff. We've been doing laws of limits, all this stuff with limits. So it's probably limits. Well, to find the slope of a tangent line, you do the slope m is equal to the limit as x approaches a, f of x minus f of a over x minus a. So let's do an example. Find the tangent line of x squared at point 1, 1. Alright, so that's pretty easy. So you lim x approaches 1, because that's the point, right? 1, 1, over x squared minus 1, because you plug in 1 into x squared and you get 1, and then you do x minus 1. So that's pretty simple, so then we just have to solve this. Well, how do we solve this? Well, that's the same as saying the limit x approaches 1 over x plus 1, x minus 1 over x minus 1. Well, that crosses out, then you just have the limit as x approaches 1 of x plus 1, and then the x is 1, so you plug in 1, which is equal to 1 plus 1, which is equal to 2. So now we have our slope of 2, and then we plug it into the point slope formula. If you guys don't remember the point slope formula, it is y minus y naught, which is the point, times m times x minus x naught, where y naught and x naught are the point. So then this, if we have this, right, y minus 1 is equal to 2 times x minus 1, right? So then you have y minus 1 is equal to 2x minus 2, add 1, y is equal to 2x minus 1. So that is the equation for the tangent line of x squared at point 1, 1. Alright, another way to find the tangent slope is with a very similar equation. And you're going to be using this one a lot because this one's a lot more helpful than the previous one we looked at. So, m is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. And then so we can see as h starts to get close to 0, f of a plus h gets very close to f of a, right? So let's do an example. We have the function f of 3 over x. F of x is equal to 3 over x. So we have to find the slope, and we're doing and then we're going to plug it in to the point slope formula for 0.31. So to find the slope first, we do limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. And this is the same as saying, I'm going to bring it up here, limit h approaches 0 of 3 over 3 plus h minus 1 over h. And that is equal to saying 3 minus 3 plus h over 3 plus h all over h, the limit of that, right? And that is equal to negative h over h times 3 plus h, which is equal to the limit h approaches 0 of negative 1, 3 plus h, which is equal to negative 1/3. So I know that was fast, but if you just plug it into the formula, you can distribute yourself, and you can do all this multiplication of fractions and stuff. Pretty simple. So now you have to plug it into the at 0.31. So you do y minus 1 is equal to negative 1/3 x minus 3. Then so you get y minus 1 is equal to negative 1/3 x plus 1, and then you add 1, y is equal to negative 1/3 x plus 2. So that's the equation of the tangent line for f of x is equal to 3 over x at 0.31. Alright, now we got to do some physics. Gross. I'm kidding, of course. It's pretty simple. So we're talking about average velocity versus instantaneous velocity. Average velocity, if you recall, is displacement over time, which is the same as saying f of a plus h minus f of a all over h, right? That makes sense. That's the equation we've already looked at previously in the previous lessons. So, instantaneous velocity, well, where does it come from? Well, I mean, if you've noticed the trend of this class thus far, we use limits. So, instantaneous velocity is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. So let's do an example. A ball falls for 5 seconds. Find its instantaneous velocity. So distance is equal to 1/2 at squared. That's an equation you just got to know. Or, well, they'll give that to you on a test or something. T is equal to 5 seconds. Your A is equal to gravity, which is 9.8 meters per second. So now we just plug it into this formula. So we got limit h approaches 0 of 4.9 x plus h squared minus 4.9 t squared. Whoops, I was saying x's at the beginning, so I just changed those to t. So now we go limit h approaches 0 of 4.9 t squared plus 2ht plus h squared minus 4.9 t squared. So then that's all over h. So then we cross out the 4.9 t squared because the 4.9 t squared is going to get canceled out. So now we just have limit as h approaches 0 of 4.9 h plus, or times 2t plus h all over h. The h's will cross out, so you have limit as h approaches 0 of 4.9 2t plus h, which is just equal to 4.9 times 2 times t, which is just 9.8, and then our t is equal to 5, So this equals 49 meters per second. So that's pretty simple. So what we can learn from this is that velocity, instantaneous rate of change, alright, so that's pretty much all for the actual physics you were doing. I mean, it wasn't even, it was just like basics. But yeah, so as we can see, you can find instantaneous velocity through our limit function. Alright, now we're going to start one of the biggest topics of Math 2A. It's derivatives, yay! Woo! So you're going to learn a lot more about derivatives, and it's going to be quite annoying. It's every lesson after, from here on out, is derivatives for Math 2A, pretty much. So, with that said, what is a derivative? It is the equation for all of the slopes in your function, right? So now on to the definition of a derivative in math language. F prime of a, that signals derivative, is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. We've seen this quite a bit. We've actually been doing derivatives without saying they're derivatives the past few questions we've done. But so a remark, the tangent line to y equals f of x at a and f of a is the line through a and f of a whose slope is equal to f prime of a, otherwise known as the derivative of f of a. So f prime of a will give you a slope, right? And so what we can learn about derivatives is the derivative f prime of a is the instantaneous rate of change of y equals f of x when x equals a. So when it says to find the instantaneous rate of change for a function or whatever it asks you for, just find the derivative. Now that's all for the lecture. Let's transition into some practice questions. Okay, now for the question, we're just going to be doing number 31. So let's do this. It says f of x is equal to 3x squared minus 4x plus 1. Find f prime of x. Okay, so we have to find the derivative of f of x. So how do we do that? Well, let's first start by writing down our formula. It's getting tiring, but it's the same formula. X plus h minus f of x all over h. And now we plug in the function. So we have 3 x plus h squared minus 4x plus h plus 1 minus 3x squared minus 4x plus 4x, because the minus will make that a plus, minus 1. And this is all over h, and then we have the limit as h approaches 0. So now we multiply this out, so we get 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x minus 1. And this is all over h, and then you have a limit as h approaches 0. So then what do you do next? Well, you want to simplify this. You know, this is looking really ugly, so how can we simplify this? Well, 3x squared, negative 3x squared. Cross those out. Negative 4x, positive 4x, negative 1, positive 1. All right, what do we have left? We have 6xh plus 3h squared minus 4h all over h. The limit as h approaches 0. So what do we do next? We take out an h, 6x plus 3h minus 4 over h, limit 0. We have that, cross out your h's. Then you just have limit h approaches 0 of 6x plus 3h minus 4, which is going to be equal to 6x minus 4. So, and that is our derivative. So the derivative to 3x squared minus 4x plus 1 is equal to 6x minus 4. So it's pretty simple. It does take a little bit of time because, well, you have to throw it into the big equation, and you have to, simplify everything correct, multiply everything correct, so there's a lot of margin for error, but it's not too hard. Alright, thank you all for watching. That's it for the video. My name was Logan.